Welcome back, guys. This is a design for a temperature monitoring system for the compost. I already made a video on this, but there were only one, two, and three sensors per arm. Um, the temperature can vary a lot. In fact, I need to even have more sensors. But I think for now this will do, and I'll just go over briefly on the components of these. First of all, these black, uh, you know, booms or whatever. Uh, it's carbon fiber tubes. My neighbor gave me when they were cleaning out their garage. It is used for um, as the stem or body of a arrow for like archery, whatever. So, and they're pretty good. In fact, the existing single sensor, temperature sensor, is using it, and seems to be pretty good. And I have some on end, and so I decided to use it this way. And then let's get rid of those, and then get rid of the main unit and antenna boards. Well, that okay. We'll come back. So each sensor is contains, let's get the containers off, contains a board and a surface mount temperature sensor and a copper thermal uh, uh, you know, copper is better than aluminum in terms of transmitting or um, temperature goes through copper much faster. Thermal resistance is lower than aluminum, so it's inside, it's embedded. This is the free SketchUp, so, and I'm having a hard time make this even with the surface, but it's machined to be even. um, these sensors, everything is pretty much done. Actually, the boards are here. I assembled some of it, um, but I am waiting on, let's say, take the boards off. I am waiting on a thermal adhesive. I ordered one from Amazon, and it is not an adhesive. It's when it quote unquote cures, it's basically like a dried out heat sink compound. It was terrible. So I ordered again what I ran out, which was the Architect Silver, uh, two parts thermal epoxy or thermal glue. So I'm waiting on that. Other than that, this thing is ready to assemble. In fact, I already assembled some of them up to here, and then I decided I need to have that nice thermal epoxy. Anyway, so um, basically all these sensors. Let's go to that. These sensors are what they do. They take, I guess I'm using 3.3. It's within its range. 3.3 and ground, of course, and it spits out a voltage um, uh, corresponding to the temperature. And if it's 0 Celsius, it outputs 500 millivolts, and for every Celsius, it um, per Celsius it's 10 millivolts per Celsius. So let's say if it's 80 millivolts the output, so subtract 500, 300, divide by 10, it's 30, so it's 30 Celsius. It's very simple. There's no complicated math or nothing. It's, if you're familiar with the metric system, divide them by 10, It's very simple. It wouldn't be hard the other way, otherwise anyway, but you can look at the, voltage and say, oh, okay, well, that's 30 volts, whatever. So, um, all these parts are machined, all the copper parts are machined. In fact, it's all done, like I said, all machined. I'm just waiting on thermal glue, and everything comes through here. So there will be a 7 wires per arm. So 5 of the sensing wires, whatever voltage coming from each of these, plus and minus, 3.3, and ground. 7 wires gonna be fed into the the module, the 2-part. I just decided to make it 2-part because if something happens to one of them, I can just replace, because I receive extra boards anyway. So if it's big, you make one mistake, you have to reorder the whole thing, and it's you know not terribly expensive, but it's not you know cheap either. So let's see, let's put all this stuff, antenna and everything, and then corners, get rid of it, and the temperature modules. Well, okay, so um 15, 3 arms and 5 sensors per arm makes 15, and the 16th one is a temperature, ambient temperature sensor. It's also copper, which is machined and isolated thermally from the case using the machine Delrin spacer, and then threaded uh, Delrin that directly threads into the copper, which sensor lives right in here again with to be arrived decent, you know, thermal glue or thermal adhesive or thermal epoxy, whatever. But I'm using the same sensor but a different package, not the uh, surface mount one. So it's the same circuitry. All it is package is different. So excuse me. So everything, all this stuff comes through from the sides, 7 wires each, and then what happens is they all go in here, left, middle, and right. 1, 2, 3, 4, 5. So when you look at the top ones, these, that's 1, 2, 3, 4, 5. So anyway, all it is it's a multiplexer mux, 3 of them, and the analog to digital sensor, which is pulled by the processor, and then it's sent to this wireless module XV, very common one. It's Wi-Fi, so it transmits to a certain port, given that the firewall is all happy about it, which I'll make changes for it. Then a server with a service, my server that with the service that I'm gonna write listens on that port, receives data, timestamps it, puts it in the database. So then it can be played back. I can animate it, maybe do some kind of temperature gradients between the sensors and find out which one's heating up and what's the situation without going anywhere. So yeah, all those 7 per come in, 5 of them go in here, and then 2 of them go here. 5 go here, 2 of them go here, 5 go here, 2, and the ambient temperature will connect here. So 16, so this is 8 to 1 multiplexer, 8 to 1, by using the processor, microcontroller I should say. You pick which one to be fed here, and you also pick which one of the inputs here are connected to output of whichever one goes. So you can iterate through by switching these quote unquote switches to feed whichever one of these voltages corresponding to the temperature to be read by the analog to digital. So it takes the voltage, like I was saying, 800 millivolts, and then scales it and gives a number back, a range, within a range. So it maps that number, it quantifies it, analog to digital. I mean, it's fairly simple. I'm just explaining it just for people's benefit. People who does not know about this stuff. Also, let's get to this one. Also, this will have a battery, and this is a battery charger, and that's the regulator, 3.3 volts regulator. This big units in green, which I use this as a common board. It's a switching regulator, 24 volts coming in, and this drops it to 5, that drops it to 3.3, which XP and everything else is working on 3.3. So that's it. Basically, just connect the antenna and then do all the settings for the XP, so it acquires the, well, it associates with the, access point. It's all done. Just send raw bytes every 10-15 minutes, and XPs are, Wi-Fi is power hungry, so I need to actually make a modifications, but I'm just gonna uh, solder wires and connector just to put this to sleep, the wireless to sleep, because even if it's not received well, I think it's using 100 milliamps, which is a lot for battery operated, system, um, just by sitting there. So turning it off, it will do 6 microamps, so it's a lot more uh, efficient, power efficient. And also, processor can go to sleep too. When it gets up, it wakes this up. In the meantime, it gathers all this, iterates through all the voltages, including ambient, and then checks to see if it's up. If it's up, associated, send those bytes. Once it's finished, shut this down, shut itself down, schedule for, cyclic sleep, whatever. Wakes up in 10 minutes or so. Or, well, something like that. No big deal. I can't even leave this on because these muxes and the ADC and the sensors, they use nothing really, microamps, or so it's not a problem. I may not just shut it down. So excuse me. So this is what I'm. Oh well, of course it has a cover, and it has a hole in the back so the power comes in, and then yeah, it has just one standoff, so the board can be mounted in there. This mounts to here, and the SMA or PSMA, whatever the regular, you know, this goes through with a nut, so it's captivated with one screw. So and the power comes through here, that 24 volts. So, and I'm thinking about installing, and I put it low enough so the battery I have can be kind of attached here. You know, you have a lot of humidity here, so I may have to like insulate the battery somewhat somehow. So this is gonna be it. And Saturday, this weekend, hopefully, if I have any extra curricular activities or missions to accomplish, given by the boss. Anyway, this should, yeah, I should be able to complete at least the sensor part of it. The boards, yep, boards are just shipped, so uh, it will be probably Monday, Tuesday, something like that. So before boards get here, I will have been done with these, hopefully. So, and if any, I will also update about, the service, the software part of it on both processor as well as the Windows service that I'm going to be building to, um, receive the data and save it to the database. So it should be fun, and hopefully it will provide some insight on the temperature changes without having to go there and poke the thing. So anyway, guys, I hope you enjoyed this video, and I will have videos of this type also, electronics and maybe some machining, which these parts are all machined and didn't, surprisingly, didn't take that much time. It's just assembly part of it to make it this compact. Assembly is really, you know, not tough, but it's just tedious, and especially if you don't have any glue that holds these in place. And just it's been terrible. So, well, we'll see you in the next video, and hope you have a good day. Take care.